Welcome to the Virtual Foundry podcast.
Hi, everybody. Thank you for joining us on the Virtual Foundry podcast. This is volume 3, episode 4. Today is Monday, April 25th, 2022. The time is 10:58 a.m. and the temperature outside is 42 degrees Fahrenheit. That's 5 degrees for you Celsius users. We had a beautiful 70-degree day the other day. We're waiting for more of those to come back through, but we're going to have to wait a little bit longer. Today, we're going to be talking about the 7th anniversary of the Virtual Foundry. We've been around for a little while. I'm Tricia Cease, the president of the Virtual Foundry, and here with me, as always, is Brad Woods, our founder, inventor, and all-around science guy. Say hello, Brad.
Hi, everybody.
So as I mentioned, today we're celebrating the official start of the Virtual Foundry, which was May 1st, 2015, although that wasn't the true beginning. Now today, the technology is ready for the world and the world is ready for it, but that wasn't always the case. So Brad, I know that you have been messing around with metal since 2001. Tell us about that. Why were you working with metal? What were you doing with it?
Right. I actually coined the term the virtual foundry at about that time. It was in the early 2000s. And my goal in life was to come up with methods of being able to sculpt in metals, but not have to have access to a foundry and not have to deal with full-on molten copper and things like that. And kind of at this time, or at least in maybe the 5 years preceding it, a lot of my friends were art students at UW-Madison, and they got access to technology that I literally only dreamed of. So I would go and tour their foundries and things like that. And it was just incredible. So my intent was to scale it down, make it simple, come up with methods that people could use at home to fabricate elaborate arbitrary shapes, whether it be sculpture or utility or whatever the application was. That wasn't my point. My point was to be able to create arbitrary shapes.
That is an interesting theme. Now, you got your first 3D printer in 2014.
Yeah, and this started at my friend Bruce. He knew that I was interested in things like this, and I had a background in information systems. I was actually a software architect, software engineer, things like that, working with big data. And 3D printing was kind of on the upside of sort of what I call the hype cycle. Everybody was talking about it, or starting to. This was pretty early in the process. And my friend Bruce, who is a no-tech person, just knew that I'd been working with these other concepts in my basement and in my garage, and saw a possible addition to the technology by adding 3D printing to it. So he literally went and bought me a 3D printer and dropped it in my lap. That was the printer bot simple, the one made with zip ties and plywood, so ultra low tech.
Now, once you got your printer and you got it started and we're printing prints in plastic, what prompted you to apply metal to this technology? Why did you go down this path?
Right. And this is sort of like the first in a series of realizations that nothing ever works the way that I expect it to. And just getting the 3D printer, because it came as a kit, so it was a lot of assembly required. Between the time when I got the kit and I made an actual 3D print successfully was probably, between 3 and 4 weeks. And I consider myself a pretty adept maker and nerd. So this was actually kind of it felt like a setback. It was very challenging to get the first 3D print off the printer. But once I did, the parts felt like the equivalent of a Happy Meal toy. They weren't relevant. And I sort of developed the philosophy at that point that without better materials for 3D printing and greater accessibility, there would be, well, the best way forward was to create new materials. And this is where I started applying my virtual foundry concept to additive manufacturing.
What did you think would be the impact of that combination of your metallurgy hobby and this new 3D printing technology?
Getting my early prototypes out the door, the concept clicked in my brain immediately. Getting to a proof of concept was very challenging. It took many hours of work, but I got it. And once I did, my expectation was that I would put it out there and the world would be clamoring for my attention, and everything would change at the moment that people looked at it. Nothing like this happened. Getting the parts out there, even once I could prove that you could make an effective part at a very low cost made out of pure metal or just about any other material, it still continued to be a challenge to convince the world that this was a good idea for many reasons, whether it was how difficult it was to work with, or whether the concept was even feasible. And honestly, I had a few people early on that spotted what I was doing and realized that it could be significant. And without support from just this handful of people, I don't know that I could have moved forward. So as an example, an engineer at Lockheed Martin spotted it. He was one of my Kickstarter people and invited me out to speak to their engineers at a conference they're having. So 1 in 1,000 people would see what I was doing and understand the significance. And yeah, that was just enough to keep me moving forward.
You mentioned Kickstarter. Tell us more about that process, why you chose Kickstarter and what the result of that was.
Right. So Kickstarter was also at the peak of its hype cycle. There were a lot of projects coming online where people would go to raise tens of thousands of dollars and accidentally raise millions. In fact, the PrinterBot Simple that I started with went exactly that way. The founder of that project, his intent was to raise tens of thousands, and I believe his Kickstarter closed at well over $1 million. So in my mind, that looked like the perfect avenue. And again, on this theme of things not working the way that I expected, Kickstarter does not work the way that anyone thinks it does. Nobody, I shouldn't say nobody, I'm sure there are exceptions, but the perception is that people come up with a good idea, put it on Kickstarter, and people throw lots of money at them. The reality is that the campaign and getting through to a successful campaign was incredibly difficult. I spent countless hours marketing. I spent every hour of every day. I think our campaign went for either 3 or 4 weeks. And I spent that entire time, lobbying, trying to get people to talk about it, trying to get magazines to publish about it, and just trying to make any noise that I could. In the end, we exceeded our goal by about 5%, which was good, but it was not simple.
So what was how did the Kickstarter and the money that you're able to raise there, how did that help the Virtual Foundry on its path?
Right. Oh, so prior to the Kickstarter, this was just a project in my basement. The kiln that I was working with for sintering things was a 4-inch cube. It was just tiny, and working with that PrinterBot Simple. The Kickstarter did a couple things. It lended credibility, was a big part of it, and we got our name out. The side effect of Kickstarter that I did, one of many that I didn't expect, was that it helped us find people that were interested in supporting the technology. And many of our early Kickstarter people continue to be customers even now. A couple of them in aerospace, a couple in art, things like that. So we raised about $30,000 on Kickstarter, and this was enough for me to go out to eBay and buy some 1990s plastic injection molding equipment and sort of reappropriate it for what we were doing here. And one of the additional challenges of bringing a new technology online is that there is no equipment for manufacturing it. So everything that we have is DIY. At some point, we'll do a shop tour, and I think that'll be kind of interesting for people because all of our equipment is reappropriated parts that I got off of curbs, treadmills, chunks of a lazy boy. But it's also, incredibly precise. But that's a whole different topic.
So continuing on the timeline, the first actual filament line was as a product was sold in 2016. What was the response to that?
Chilled. It was not the clamoring that I expected. Early versions of the product were difficult to work with. Getting a 3D printing filament in it that has enough metal to sinter well does not want to be strong by any means. So I'm going to try a couple props here, but this is early versions of, this is our stainless 316L, and this is from about that time period. But it's brittle. It's making it hard to work with. You can work with it. You can get it to print, and lots of our users did. But it was a challenge, and we're already asking people to try something new, and then putting a big challenge between something new and success made it a little bit extra difficult. So over time, we've improved our manufacturing process. You could even say that it's a completely different product. I mean, chemically it's similar, but most things about it have changed except for the metals themselves. So this is our 316L today. And you can wrap it around your finger. It's stronger than it needs to be, actually. And the second piece I showed you actually has more metal in it than the first one that I showed you. So over time, refining the manufacturing process was an enormous challenge.
So along with improving the actual product itself, the other significant improvements that have been made in how to use it.
Right.
So the helping the flexibility of the filament along with the development of the filawarmer, really refining those heat processes, the debind and the sintering that happens in common kiln equipment. You've put a lot of work, and our partner innovators have put a lot of work and development time as well into really refining those debind and sintering processes.
Right. And one of the aspects of this that I don't think we can understate is the contribution from the general public. Huge numbers of people that understood what we were working toward here saw it and had the aha moment, and many of them took the technology and helped us move it to the next step. So this has been a big part of the process. One of the things that I think is interesting is, you look at this and it looks like a scientific endeavor. A part of it that's difficult to explain and difficult to understand is that some of our greatest revolutions were not technological or chemical or anything like that. It was us coming to understand how this can be applied in the market and how it can be used. And people's instinct is they'll look at what we're doing and they'll say, okay, well, then now I don't need to machine parts anymore. I don't need to use my lathe. And that's not what this is about. This technology is to augment existing technologies. We don't want to replace or expect to replace the parts that are already out there or how they're manufactured. This is a new method of solving problems that haven't been solved before.
Now, along with solving new problems, one of our favorite products that we sell is Rapid 3D Shield Tungsten Filament, and this came about as a commissioned product. So someone approached Brad, asked him to make a non-toxic 3D printable radiation shielding material. Brad, tell us how all of that unfolded.
Right. So at the core of our product is it's a bunch of metal held together with a thermoplastic. And so this can be applied in many different ways. So one of the people that we work with, a company called Vulcan GMS, the guy that started that company was trying to come up with a non-toxic 3D printable lead replacement for radiation shielding. And he knew that all you really had to do was put a bunch of high density metal into a thermopolymer and he was done. And kind of what makes it interesting is he's from Milwaukee, which is only about 175 miles from here. And he had literally traveled around the globe. He talked to Color Fab. He talked to anybody that had been making composite 3D printing filaments. And none of them could load enough material into it to make it block radiation shielding on par with lead, and it really wasn't worth doing if you couldn't get it to compare with lead. And then and he'd been calling me and I wasn't sure about this project and I'd kind of been brushing him off a little bit. And then I was at Maker Faire in Milwaukee and he walked up in front of me and he didn't say anything. He just held up his card with his name on it and smiled and was like, yeah. So I couldn't avoid him anymore. He was standing right in front of me. And it turned into one of the Virtual Foundry's more interesting collaborations. So now we make this non-toxic lead replacement, and we ship this stuff all over the world. I mean, it's used in applications that you just don't think of. And on that topic, his company, lead products are everywhere. You think of lead as being kind of obsolete and old, but it's a part of everybody's lives. It's just dealt with much more carefully than it was 50 years ago.
So you spoke about this particular product being in use all over the world. And indeed, all of our products are in use all over the world. We do really have a global customer base. And that's one of the most fun things for me about this work is working with people from all over the world. So we know that lots of people are finding lots of uses for it. And before we talk about that, tell us who it's not for. Tell us who is really not using it, along with the theme of none of this is going how you expected.
Right. Okay. Yeah, this is interesting. So the obvious, or what I thought the obvious market for our materials would be, are the people that are currently 3D printing with plastic. I thought this would be incredibly well received by that group. I mean, how could it not? You can make metal parts on the printers that you're working with right now. But what actually happened is and I'm not sure how to describe this group of people, but they're the makers, they're the people at home, they're the people that talk about 3D printing the most. I thought that they would be excited about this, and that hasn't been the case, and it continues to not be the case. Part of it is cost. Our material is much more expensive than plastic, and if you try to compare the two on that property alone, it doesn't compare favorably. And what we're putting out there is highly disruptive. This is unlike anything that has been out there before. It's a new strategy.
You mentioned cost, and I want to explore that a little bit because it's true. If you're used to 3D printing on your FFF, FDM style 3D printer in plastic, and then you look at the metal filaments offered by the Virtual Foundry, you might have a little sticker shock. But conversely, if you're looking at metal 3D printing and the other technologies that are available, and you come to the Virtual Foundry and look at the investment required to get full metal parts from equipment that you probably already have, wow, it's amazing the difference. It's a 10x savings over the other methods of metal 3D printing.
Right. You have to look at it in the context of the cost of producing your first metal part, whether you're metal injection molding or casting, machining, whatever. The cost of the very first part is the most is incredibly prohibitive. And this is part of the problem with prototyping, is that when you make a prototype, you know you're going to need to change it. So you don't want to put $20,000 into tooling equipment. That doesn't make sense. So when you look at metal 3D printing in that context, then it starts to make sense. The downsides, and this is something that maybe the industry will overcome in time, but it's going to be challenging, is that economies of scale don't apply well to metal 3D printing. As you get to a volume of 10x, you don't get to 1/10 of the cost. It doesn't work that way. It stays pretty flat. So, from that angle, I'm not sure how that'll work out. But yeah, if you look at everything in the context of the cost of the first part made, there is no less expensive method of making a metal part than 3D printing, and specifically using the Virtual Foundry's technology, which is relatively low technology, simple hardware, and accessible existing equipment.
And producing the same metal part.
Correct.
So that brings us to who is using it. And because this process provides so much flexibility, you have control over every step of the process. It's really today found its home in research.
Yep. Yeah. Right. And I think this generally tracks with each of the revolutionary technologies that have come along in the past few decades, or I guess 2 generations at this point. But if you track the way that the internet worked its way into everyday lives, this is where it started. It started in research. It started with very smart people thinking way outside the box. And similar to computing, it followed a similar track. So were it not for research and people trying to solve new problems, it never would have gotten to where it is now. And this is true with both 3D printing and metal 3D printing especially. We're just at the beginning of this journey.
Yes, and that whole research segment is so important because, as you said, this is not a replacement technology. It's not evolutionary. It's revolutionary. It's a whole new way to get metal into any arbitrary shape that you want. The full possibilities need to be explored, and truly, we are at the very beginning of figuring out what can be done with this technology.
Right. I would say the key part of my job at this point is to be an ambassador, to get out and help people understand how to apply the technology. We've gotten this to a point where it can be implemented, it works well, whatever, you can prototype with it, that kind of thing. But the next generation of applications are what's going to make it interesting. And we want people to stop thinking of in the context of traditional fabrication techniques. This isn't, like you said, this isn't an evolution of that technology. It's a revolution. It is different and needs to be thought about differently.
So continuing on that timeline, we really should touch upon the thing that happened to all of us all over the world, the old COVID.
Yeah. So, right, as the Virtual Foundry was gaining traction, we found our people in research. Universities definitely at that point were our absolutely core customer base. We shipped all over the world. People were experimenting with this stuff. And yeah, I'll let you speak to the numbers, Tricia, but month over month, COVID was devastating for us.
March to April of 2020 saw an 83% decrease in revenue as all of the universities all over the world shut down, sent students home, and all of their research came to a grinding halt.
Right. And this is an incredibly short time period. We're talking, 3 or 4 weeks. We went from a a growth trajectory that was at a 45-degree angle going up aggressively to just tanking. It was like sweeping our feet out from underneath us. It was incredible.
But look, we're scrappy and resilient, right? We're still here. I know a lot of companies didn't decided to make other decisions during COVID. Was there a point that you thought maybe this would spell the end?
No. And I've never thought that from the beginning. Our general mission stays the same. Our basic core technology stays the same. Nothing about it has changed. What has changed is people's perception over time and their understanding of how these things work. It's taken a very long time for the world to accept what the virtual foundry is putting out there. It's different, and I get it. After 7 years, and like I said early on, I expected to be received with open arms, and in some cases we're considered more of a a heretic or something like that. We weren't. It wasn't what I expected. But in that context, and all the other things that we had overcome over time, COVID was just sort of another speed bump. I knew we would get through it. And I knew our finance strategy at that point became a strategy of buying time, surviving long enough that the world could heal and recover from COVID. And we're back on track.
Yes. And after 7 years, we're now at the beginning. As I said when we opened, the world is now ready for this technology, and this technology is ready for the world. And collectively, we're starting together.
Yeah. It seems improbable to say that after 7 years, we're ready to get going, but that's where we are. And we're doing things that people haven't seen before. And so I 3D printed, this is some chainmail that I made. So this is pure copper. It's incredibly flexible. It's very strong. It has all the properties of copper, electrical and thermal conductivity. And my story that goes with this when I show it to people is that it's not important that this is a piece of chainmail. What's important is that it's an arbitrarily created metal shape, and it could be any shape that you can think of. So as people are going to solve problems, they can approach it from this perspective rather than picturing how am I going to mill this part and then adapting your design to the technologies that are available. It's incredibly liberating to know that you can just create whatever shape you want.
So Brad, happy anniversary to you. Congratulations on your invention. Congratulations on all of the ways that our partner innovators are joining with us, supporting the Virtual Foundry as we all move forward with metal 3D printing together. And I do have one more very important question for you before we wrap up today.
All right.
Did you hear about the claustrophobic astronaut?
I don't think so.
She just needed some space.
Nice.
That's it for today. Thank you for joining us for the Virtual Foundry podcast. If you have a cool project you want to showcase in one of these podcasts, or if you have a topic you would like us to discuss, we would love to record that for you. Reach out to us at info@thevirtualfoundry.com, and we'll see you next time.
Thanks, everybody.
I'm going to back up and pause and ask you. Oh, no. Okay, hold on. Just hold on for a few seconds.